Introduction to RNN. Recurrent neural networks or RNN are a type of neural networks where the output from previous step are fed as input to the current step. A good example can be when it is required to predict the next word of a sentence, the previous words are required and hence there is a need to remember the previous words. So this is the whole logic behind developing the RNN. If you see this figure very carefully, we have a very significant difference in the structure of the artificial neural network that you have already studied and the recurrent neural networks. So in artificial neural network, you had different hidden layers and all were separate. So all were densely connected. Each neuron had this weight and bias attached to it. But in RNN, you have a feedback loop and the input from the previous state is given back as the output from the previous state is given back as the input to the current state. So this is your main input where you take all the features from your dataset, and here you have some hidden layers in RNN where you have a feedback loop and input from the output from the previous state is given as input to the next state, and finally after doing this for different timestamps you have a final output of the RNN. Let's understand this hidden layer in RNN. So you have this timestamp 1 x1, timestamp 2 x2, timestamp 3 x3. You have an initial bias at 0 and a y1, that is output of the first state, output of the second timestamp, output of the third timestamp, and here you have a single activation function unit. So this is the hidden layer in RNN. Now function of a neuron in RNN. So if you see the structure of the neuron, you have this x at time 0 xt, ht of 1, that is the bias coming from the previous timestamp t minus 1. Here you have some initial weight and then you calculate the parameterized vectors over here. In RNN we use the tanh activation function, which is also known as the hyperbolic tangent. So calculate element wise hyperbolic tangent, and this new ht is given as the same neuron that is attached over here for the next xt plus 1. So this is the neuron structure for xt. Again you will be having a neuron structure for xt plus 1. Function of a neuron in RNN. So firstly we have to calculate the current hidden state, that is ht, and we'll calculate this using the function weight, and xt and h of t minus 1 will be given. Finally this h of t, and you will take the tanh function of these two and will add them. The output will be this weight multiplied by ht for the current state, that is yt. We won't be going in much complex mathematics for the RNN. So this is the basic multiplication that takes place over here. Now let's understand training in RNN. A single time step of the input is provided to the network. Then we calculate its current state using the set of current input and previous state. The current ht becomes ht minus 1 for the next time step. One can go as many time steps according to the problem and join the information for all previous states. A very popular use of RNN is working with time series data. So in the next few videos, you will see the practical implementation of RNN when we try to predict the price of a stock. So in a stock market data, you have data for daily open, close, high and low. So let's say on 1st January, this is the closing price of the stock. On 2nd January, XYZ is the closing price of stock, and on 3rd January, ABC is the closing price of stock. So for different time steps, you are having different data. So to work with that kind of data, mostly RNN is used. That's why timestamps and time steps are involved over here in RNN. In the next video, it will be very clear to you when we try to implement RNN for stock price prediction. Once all the time steps are completed, the final current state is used to calculate the output. The output is then compared to the actual output, that is the target output, and error is generated. The error is then backpropagated to the network to update the weights, and hence the network RNN is trained. The error is propagated back, which is very similar to your ANN. We first calculate the output, and once we check the predicted output with the actual output, and then we calculate the error, that is the difference between your predicted and actual values. And to reduce the error or to minimize the difference, we change or update the values of weights and biases in the network. So that is pretty much same in RNN training. This is the visualization. You have a single activation function unit, and these are different time steps x1, x2, x3, x4, and h1, h2, ht minus 1. It goes on, and finally the error is backpropagated, and all these weights and biases will be changed in RNN. So gradient descent issued with chain rule to update the weights. Now chain rule is used for gradient descent. Therefore RNN may have two problems. The first one is vanishing gradients and exploding gradients. These two problems we discussed in detail in ANN. And to overcome these two problems, two variations of RNN are proposed, namely long short-term memory networks and gated recurrent neural unit networks. So LSTM, which is a very popular version of RNN, in concept, an LSTM recurrent unit tries to remember all the past knowledge that the network has seen so far to forget the irrelevant data. This is done by introducing different activation function layers called gates for different purposes. Each LSTM recurrent unit also maintains a vector called internal cell state, which conceptually describes the information that was chosen to be retrained by the previous LSTM recurrent unit. This is the structure of LSTM. Let's study about different gates that are used in LSTM. The first one, that is forget gate, and it is denoted by F. So it determines to what extent to forget the previous data. Second gate is input gate, that is determined denoted by I. It determines the extent of information be written onto the internal cell state. The third one we have input modulation gate, or G. It is used to modulate the information that the input gate will write onto the internal state cell by adding non-linearity to the information and making the information zero mean. This is done to reduce the learning time, as zero mean input has faster convergence. That's why we use the input modulation gate, and that is denoted by G. Finally, we have the output gate, that is denoted by O. It determines what output or the next hidden state to generate from the current internal state. So these are the different gates that are used in LSTM. I'll show you the visual representation of these gates. So as you can see, we have different gates and different activation function used over here, mostly sigmoid and tanh, and finally this tanh function is used over here. So all these multiplications are performed, and then finally the output is sent to the next step. So let's understand the working of LSTM. We first take the input and the current input, the previous hidden state and previous internal cell state. Then we calculate the values for 4 different gates by following these below steps. For each gate, calculate the parameterized vectors for the current input and the previous hidden state by element-wise multiplication with the respective weights for each gate. Apply the respective activation function for each gate, element-wise on parameterized vectors. Then we calculate the internal cell state by first calculating the element-wise multiplication vector of the input gate and the input modulation gate. Then calculate the element-wise multiplication vector of the forget gate and previous internal state, and then adding these two vectors. And finally, we calculate the current hidden state by first taking the element-wise hyperbolic tangent or the tanh activation function that we use of the current internal cell state vector, and then performing element-wise multiplication with the output gate. So this is a little complicated mathematical terms that are used over here, but all this will be more clear to you when we try to implement RNN practically using TensorFlow and Keras in the next videos of the course. So I hope you are clear with the basic understanding of what is RNN in deep learning. Thank you for watching. Now let's move to the next video.